The electricity going through the flame is alternating current, or AC. The sensor picks up both alternating current and direct current, or DC, but the direct current is what makes the circuit work. The alternating current is not enough to affect the circuit. Let's examine a more detailed explanation of how the flame sensor works. The flame sensor is a metal rod that is inserted into the flame. The rod is heated by the flame, and this causes it to emit electrons. The electrons flow through the rod and create a current. This current flows through a resistor, which converts the alternating current to direct current. The direct current is then used to power the circuit. The circuit contains a relay, which is a switch that is controlled by the current. When the current is high enough, the relay closes and allows electricity to flow through the circuit. This electricity is used to power the gas valve, which opens and allows gas to flow to the burner. If the flame goes out, the current will stop flowing and the relay will open. This will shut off the gas valve and prevent gas from flowing to the burner. Flame sensors are an important safety device that help to prevent gas leaks and explosions. So, to reiterate, a flame sensor operates using the principle of flame rectification. When a flame is present between two electrodes, it acts as a rectifier, allowing current to flow more easily in one direction than the other. This creates a direct current signal that can be detected by the flame safeguard control system. This system then keeps the gas valve open, allowing the burner to continue operating. If the flame goes out, the rectification process stops, the direct current signal disappears, and the flame safeguard control system shuts off the gas valve. The flame sensor itself is typically a metal rod made of materials like candle or similar high-temperature alloy. It is positioned so that it is directly in contact with the flame. The flame sensor is connected to the flame safeguard control module. The flame safeguard control module is an electronic device that monitors the direct current signal from the flame sensor. If the direct current signal is present, the module keeps the gas valve open. If the direct current signal is absent, the module shuts off the gas valve. The flame rectification process is affected by several factors, including the flame temperature, the distance between the electrodes, and the composition of the gas. The flame temperature must be high enough to ionize the gas, which creates the charged particles that are necessary for current to flow. The distance between the electrodes must be small enough so that the charged particles can easily travel between them. The composition of the gas must be such that it is easily ionized. Flame sensors are used in a variety of gas-fired appliances, including furnaces, boilers, and water heaters. They are an important safety device that helps to prevent gas leaks and explosions. Some common problems that can occur with flame sensors include the sensor becoming dirty or corroded, the sensor becoming misaligned, and the flame safeguard control module malfunctioning. If the sensor is dirty or corroded, it may not be able to detect the flame properly. If the sensor is misaligned, it may not be in contact with the flame. If the flame safeguard control module is malfunctioning, it may not be able to properly monitor the direct current signal from the flame sensor. If you are experiencing problems with your gas-fired appliance, it is important to have it inspected by a qualified technician. A technician can diagnose the problem and make the necessary repairs. Here's a more detailed breakdown of the process. Firstly, alternating current voltage is applied to the flame rod. This alternating current signal is supplied by the flame safety control. Secondly, when a flame is present, it creates an ionized path between the flame rod and the burner ground. This ionized path allows the alternating current to flow through the flame. Thirdly, the flame acts as a rectifier, allowing current to flow more easily in one direction than the other. This creates a direct current signal superimposed on the alternating current signal. Fourthly, the flame safety control detects the direct current signal. The strength of the direct current signal indicates the presence and stability of the flame. Fifthly, if the direct current signal is strong enough, the flame safety control keeps the gas valve open, allowing the burner to continue operating. Sixthly, if the flame goes out, the ionized path disappears, the direct current signal stops, and the flame safety control shuts off the gas valve. The flame rectification method is reliable and safe because it requires a continuous flame to maintain the direct current signal. If the flame is interrupted for any reason, the gas valve will immediately shut off, preventing the accumulation of unburned gas. Factors affecting flame rectification can be: 1. Flame quality. A strong, stable flame produces a stronger direct current signal. A weak or flickering flame may produce an intermittent or weak direct current signal. 2. Flame rod condition. A clean and properly positioned flame rod is essential for reliable flame detection. A dirty, corroded, or misaligned flame rod may not be able to detect the flame properly. 3. Gas composition. The composition of the gas can affect the flame's ability to conduct current. Some gases are more easily ionized than others. 4. Voltage. The alternating current voltage applied to the flame rod must be within the specified range. Too high or too low voltage can affect the direct current signal strength. 5. Ground connection. A good ground connection between the burner and the flame safety control is essential for proper flame rectification. A poor ground connection can cause erratic flame detection. The alternating current voltage is typically around 120 volts alternating current. The direct current signal is typically a few microamps. The flame rod is typically made of a high-temperature alloy such as Kanthal. The flame safety control is typically a solid-state electronic device. To summarize, the flame sensor utilizes a phenomenon called flame rectification to detect the presence of a flame. This involves using a metal rod, the flame rod, positioned in the flame. An alternating current voltage is applied to the flame rod. When a flame is present, it ionizes the air and creates a conductive path between the flame rod and the burner, which is grounded. This completes the circuit. The flame acts as a rectifier, allowing current to flow more easily in one direction than the other. This results in a small direct current signal. The control module detects this direct current signal and interprets it as the presence of a flame. If the direct current signal is strong enough, the control module keeps the gas valve open, allowing the burner to continue operating. If the flame goes out, the ionization stops, the direct current signal disappears, and the control module shuts off the gas valve, preventing gas from accumulating. It is important to note that the alternating current is used to establish the initial current flow, but it is the direct current signal that is actually detected and used for flame proving. Now let's delve a bit deeper into the components and their functions. Firstly, the flame rod. This is typically a high-temperature alloy rod, such as Kanthal, that is inserted into the flame. It acts as one electrode in the flame rectification circuit. Secondly, the burner. The burner acts as the other electrode in the flame rectification circuit and is typically grounded. Thirdly, the flame safety control module. This is an electronic module that provides the alternating current voltage to the flame rod, detects the direct current signal, and controls the gas valve. Fourthly, the gas valve. This valve controls the flow of gas to the burner. It is opened and closed by the flame safety control module. The flame rectification process is affected by several factors, including 1. Flame temperature. A higher flame temperature results in greater ionization and a stronger direct current signal. 2. Air-fuel ratio. The air-fuel ratio affects the completeness of combustion and the concentration of ions in the flame. 3. Electrode spacing. The distance between the flame rod and the burner affects the strength of the direct current signal. 4. Electrode surface area. A larger electrode surface area results in a stronger direct current signal. 5. Gas composition. The composition of the gas affects its ability to be ionized. Flame sensors are an essential safety component in gas-fired appliances. They help to prevent gas leaks and explosions by ensuring that the gas valve is only open when a flame is present. In addition to the components already mentioned, there are some additional factors that can affect the performance of a flame sensor. One is the type of gas being used. Some gases are more easily ionized than others, and this can affect the strength of the direct current signal. Another factor is the presence of contaminants in the flame. Contaminants can interfere with the ionization process and reduce the strength of the direct current signal. Finally, the age and condition of the flame sensor can also affect its performance. Over time, the flame rod can become corroded or damaged, which can reduce its ability to conduct current. It is important to inspect the flame sensor regularly and replace it if it is damaged or worn. When troubleshooting a flame sensor, it is important to first check the basics, such as the gas supply, the ignition system, and the wiring connections. If these are all in good working order, then the problem may be with the flame sensor itself. To test the flame sensor, you can use a multimeter to measure the direct current signal. If the signal is weak or non-existent, then the flame sensor may need to be replaced. It is also important to clean the flame rod regularly to remove any deposits that may have accumulated on it. Flame sensors are an important part of any gas-fired appliance, and it is important to understand how they work and how to troubleshoot them. By following these tips, you can help ensure that your gas-fired appliance is operating safely and efficiently. In conclusion, flame sensors are a crucial safety component in gas-fired appliances, utilizing flame rectification to detect the presence of a flame and prevent gas leaks. The alternating current serves to initiate the process, while the resulting direct current signal confirms the flame's presence, ensuring safe and efficient operation. Regular inspection and maintenance are essential for optimal performance and safety.